in an unforeseen twist of affairs. NASA's James Webb Space Telescope has made a trailblazing discovery that has astounded astronomers globally. Only a few weeks ago, the telescope revealed the earliest documented galaxy in the universe. However, now it has pinpointed something even more remarkable: a splendidly massive black hole that is rapidly moving away from its host galaxy at a stunning speed of 4 million miles per hour. This revelation carries profound ramifications and has ignited massive discussion and intrigue among scientists and space enthusiasts alike, particularly concerning its potential influence on our understanding of the cosmos. The James Webb Space Telescope was deployed with the goal of investigating the first galaxies in the cosmos, and it has already captured breathtaking imagery of the death of stars and galaxies dating from just a few hundred million years after the Big Bang. We welcome you to accompany us as we delve further into these most recent discoveries from this extraordinary telescope. Be sure to like and subscribe for more updates like this. This new discovery challenges prevailing scientific theories, especially concerning black holes. Traditionally, black holes are deemed vast forces that attract everything, including light, into their centers. Yet, this recently detected black hole appears to defy those expectations. Instead of absorbing light, it seems to be creating new stars along an elongated path, which has been observed in its wake. This string of youthful stars extends a mind-boggling 200,000 light-years. The strange behavior of this black hole has left scientists puzzled. However, a group led by Professor Peter B., an authority in astronomy, has recently published their conclusions in astrophysical journal letters. NASA's observatory also confirmed these findings, implying that this black hole initiates the birth of new stars by interacting with surrounding gas and cooling it. We are witnessing the effects of the black hole's movement, and this is merely the beginning. Moreover, NASA has introduced another exciting update about the galactic collision, ARP-220, also captured by the James Webb Space Telescope. This extraordinary galactic merger can be seen radiating brightly among other galaxies in the night sky. When spiral galaxies collide, the resulting phenomenon ARP-220 glows most brightly in the infrared spectrum, making it ideal for observation by the James Webb Space Telescope. It is categorized as an ultraluminous infrared galaxy, possessing a luminosity equal to 1 trillion suns, far outshining our Milky Way, which has a luminosity of approximately 10 billion suns. Situated in the constellation Serpens, ARP-220 lies at a distance of approximately 250 million light-years and is considered the brightest of the three nearest galactic collisions to Earth. This galaxy is catalogued as item number 220 in the Atlas of Peculiar Galaxies. Around 700 million years ago, two spiral galaxies merged, provoking a tremendous eruption of star formation. That event generated a dense region approximately 5,000 light-years across, home to about 200 massive star clusters. Amazingly, this compact region holds as much interstellar gas as the entire Milky Way. Earlier observations with radio telescopes identified almost 100 supernova remnants within a 500 light-year radius. The James Webb Space Telescope further discovered that the central galaxies are separated by 1,200 light-years, each containing a rotating ring of star formation emitting intense infrared radiation. Fresh images from the telescope depict the merging galaxies in exquisite detail, emphasizing subtle tidal tails stretching outward from the merger of evidence of the gravitational pull between the two structures. The reddish and orange streaks and filaments represent dispersed or ionized material in ARP-K200. Another incredible revelation astonished scientists when researchers identified primordial galaxies located at the edge of the universe. At first, there was skepticism about their authenticity, with some hypothesizing they might be nearer galaxies masquerading as ancient ones. To verify the findings, the data was shared globally. To their amazement, the James Webb Space Telescope confirmed that these ancient galaxies are indeed real. Thanks to this modern observatory, we can now observe the oldest galaxies ever documented. Astronomers deduce that light from these galaxies has traveled more than 13.5 billion years to reach Earth, offering us insight into the universe's distant past. These galaxies were detected when the universe was in its infancy, yielding critical insights into the rapid formation of the first generations of galaxies. Spectral data confirmed that these galaxies lie at the outermost boundary of our observable universe, with some potentially beyond the capabilities of even the Hubble Space Telescope. This finding is pivotal, as it upholds one of the primary missions of the James Webb Space Telescope to explore the early universe through light, having journeyed over 13.5 billion years. The telescope's ability to detect high redshifts sets it apart, allowing astronomers to probe the infrared realm and observe the earliest galaxies. The euphoria surrounding this discovery is palpable, as it marks a major milestone in cosmic exploration and our grasp of the universe's evolution. The results have had a profound impact on our understanding of the cosmos and have propelled NASA to pursue even more sophisticated telescopes to deepen our knowledge of the Big Bang. Data from Webb's exceptional guidance sensor, spectrometer, and near-infrared camera revealed that 4 of the 6 primordial galaxies exhibit high redshifts, implying Webb is observing them as they existed between 300 and 500 million years after the Big Bang, with a notable lack of heavy elements like carbon. This is startling, considering the universe is estimated to be 13.8 billion years old, and the presence of such galaxies demands a revaluation of our understanding of the early universe. This revelation has raised alarm in the scientific community because it contradicts current cosmological inflation models and the Big Bang theory, both of which include certain inconsistencies such as defying thermodynamic laws and lacking a clear origin explanation. Moreover, the James Webb Space Telescope has identified galaxies nearly as old as the Big Bang itself, which casts doubt on long-held beliefs about the universe's genesis. Theoretical physicist Michio Kaku has asserted that uncovering these ancient galaxies compels us to reevaluate everything we thought we knew about the universe's origins. Previously, these galaxies were assumed to be less evolved than the Milky Way, but the new discoveries suggest we may be overlooking crucial information. The fact that the telescope detected 6 galaxies that existed just 500 million years after the Big Bang and that they are up to 10 times larger than the Milky raises major questions about whether our current theories of cosmic creation are accurate. Kaku explained that it typically takes billions of years to form a galaxy like the Milky Way, making it puzzling to discover such enormous young primordial galaxies. This finding could necessitate a complete overhaul of textbooks on the universe's origin. The discoveries made by the James Webb Space Telescope challenge our former comprehension of the Big Bang, leaving scientists at a crossroads. Nevertheless, NASA recently announced the discovery of a galaxy cluster located just 650 million years after the Big Bang, adding yet another fascinating piece to the puzzle. Astronomers have examined the data and determined that this nascent cluster is expected to expand and eventually resemble the massive coma of 656 cluster. This finding is particularly significant because it lies in a region experiencing rapid galactic evolution thanks to the James Webb Space Telescope. Researchers can now measure the velocities of those 7 galaxies, confirming that they may be bound together in a protocluster. To contextualize, NASA scientists liken these distant galaxies to tiny droplets in distinct rivers, all ultimately converging to form a mighty river. Truly, what we once believed about the Big Bang does not align with the emerging facts. However, more evidence from the Webb telescope may soon provide proof to validate or refute these theories. Whether the Big Bang truly occurred remains undetermined. But the cause of it might be an entirely different narrative. We may need to wait for further discoveries, but the answers might be closer than expected. What are your perspectives on these revelations? Share your thoughts in the comments below, and I'll catch you in the next video. Thank you for watching. As the James Webb Space Telescope continues its transformative mission, the scientific community eagerly anticipates further revelations that could reshape our understanding of the universe. With each new breakthrough, the telescope is extending the limits of what we deemed possible, presenting us with a clearer, more refined view of the cosmos. Its ability to observe the faintest and most distant galaxies allows astronomers to reconstruct the early history of the universe, illuminating events that occurred billions of years ago. The consequences of these discoveries are vast, as they challenge long-standing theories about galaxy formation and evolution. If these newly observed galaxies are indeed as primordial as they appear, this raises profound questions about the speed at which galaxies can grow and mature. How could these massive, mature galaxies have formed so unexpectedly after the Big Bang? Might there be unknown mechanisms at work that we have yet to realize? The James Webb Space Telescope's ability to capture such meticulous detail is likely to yield even more revelations in the coming months and years. Moreover, insights from studying these ancient galaxies will assist astronomers in refining their models of cosmic evolution. By studying the development of these early galaxies, scientists hope to better understand how the universe transitioned from its chaotic early phases to the structured form we observe today. The role of black holes in this evolution, particularly their influence on star formation and galactic development, remains a central research focus. Another fascinating aspect of Webb's observations is its potential to observe star formation within these ancient galaxies. In addition to revealing black holes that seem to defy our expectations, the telescope has identified regions where stars are forming at a tremendous rate. These zones of intense star birth could offer key clues about how the first stars emerged and what conditions were necessary for their development. As researchers continue to analyze data from the James Webb Space Telescope, it's clear that these discoveries are merely the beginning. The telescope's unmatched sensitivity and cutting-edge capabilities make it an invaluable tool for probing the furthest reaches of space. In the future, it is expected to uncover even more enigmas about the universe, from the origins of galaxies to the very nature of dark matter and dark energy. While the discoveries so far have already transformed our comprehension of the cosmos, the journey is far from over. Scientists are only beginning to scratch the surface of what the James Webb Space Telescope can uncover. As fresh data accumulates, the telescope will continue to challenge entrenched theories, offering new insights and igniting fresh debates concerning the universe's most foundational mysteries. The excitement surrounding these discoveries is not limited to scholars. Space enthusiasts and the general public alike have been captivated by the stunning visuals and paradigm-shifting findings that the Webb has delivered. The telescope has rekindled interest in cosmic exploration and inspired a new generation of astronomers, physicists, and cosmic enthusiasts to gaze upward with awe and wonder as we continue probing the depths of space. One truth remains: the James Webb Space Telescope has opened a new chapter in our pursuit to understand the universe. With each discovery, we inch closer to answering some of the deepest questions about reality, the origins of life, and the fate of everything in it. In conclusion, the discoveries unveiled by the James Webb Space Telescope have profoundly impacted our grasp of the universe. From the earliest known galaxies to the identification of spectacularly massive black holes that forge new stars, the telescope is reshaping our cosmic perspective. That, as the mission continues, we can expect further breakthroughs that will challenge our prevailing models of the universe and inspire future scientists to persist in exploring the vast unknown. Thank you for accompanying this exhilarating journey. And stay tuned for more updates on the James Webb Space Telescope and its extraordinary findings. The James Webb Space Telescope's discoveries herald a new era in space exploration, marking a major shift in our cosmic understanding. Its innovative structure and unparalleled capabilities allow astronomers to observe distant galaxies, star systems, and cosmic phenomena in ways previously unimaginable. This telescope is not merely an apparatus for observing celestial objects, but a window into the distant past, offering a unique perspective on how the universe evolved. From its earliest moments, one of the most exciting aspects of the James Webb Space Telescope is its ability to detect objects billions of light years away. This allows scientists to capture snapshots of galaxies as they appeared shortly after the Big Bang, providing a glimpse into the infancy of the cosmos. The telescope's infrared vision is especially adept at detecting these ancient galaxies, which are often too faint or distant to be seen with other instruments. These observations offer essential insights into the processes that led to the birth of the universe's earliest structures, revealing how foundational elements converged over time. As the telescope continues to survey the universe, its findings are challenging many assumptions held by scientists for decades. For instance, the discovery of galaxies that coalesced so unexpectedly after the Big Bang suggests that our current frameworks for galaxy formation may require revision. These revelations compel us to contemplate how galaxies evolve so efficiently and whether there are hidden factors influencing this development that remain undiscovered.